Hey guys, what's up? So today I want to show you how you can compute the derivative of inverse sine using implicit differentiation, okay? So what we want to find is the following. We want to find d over dx of sine to the -1. This is also sometimes it's called arc sine, okay? Arc sine of x is the same as sine to the -1 of x, and these two things, well, you can call them inverse sine. So how are we going to find this derivative? Well, we're going to define a variable that is going to be y, and we're going to say that y is equal to sine to the -1, or basically inverse sine. And now we want to define a new variable, which I'm going to call w. I like w. And we're going to say that this is going to be sine x, okay? Now, you should know this if you're studying calculus. You should know that there is a relationship between w and y and w. If you evaluate w at x equals y, that is w of y, which is going to be the same as sine of y, this is going to be equal to x, okay? Because sine of y is the same as sine of inverse sine, okay? And you should know that this returns x, okay? This function will give you x back. So now, why is this important? Well, we have these two. We have this equation, and to find dy over dx, we can differentiate. I remember dy over dx is going to be the derivative of inverse sine. So if we want to find dy over dx, we can differentiate this equation over here using implicit differentiation, of course, okay? Because this is an implicit equation. So that's what we're going to do. So we know that the derivative of this equation is going to be d over dy of sine y times the derivative of y with respect to x, okay? This is just the chain rule. And the derivative of x, well, we know it's just going to be 1. And now we can just simply solve for dy over dx. We know the derivative of sine is going to be cosine y. And we're going to move this cosine y to divide on the other side of the equation. So you have that dy over dx is going to be equal to 1 over cosine y, okay? So this is how much we get. This is going to be the implicit solution. The implicit solution in calculus is going to be a solution that is only in terms of another variable that is not the variable that you want. So in this case, we have y, but we don't really want y because we want dy over dx, not dy over dy, or we don't want y in terms of y. We really want to have this result in terms of x. So we need to somehow replace cosine y with something. And something you can do is use a right triangle, and I'm going to show you what happens. So you know that sine of y equals x. If you want to translate that information into a right triangle, so I'm going to say we have this. Let's say this angle is going to be y. If sine y equals x, well, you know that sine y is going to be the opposite side over the hypotenuse. So the opposite side would be this side over here, which could be the height, and the hypotenuse is going to be, well, the longest side of the longest side of the triangle. So if we only get x, well, that means that the hypotenuse must be 1. This side must be x, okay? So we get x. And now, well, the only thing that we're missing is we need to figure out how much this side is, because we know that, I'm going to continue over here, cosine y is going to be equal to the adjacent side, which is going to be this one, over the hypotenuse. The hypotenuse is 1, so we don't really bother, we don't really consider anything, okay? About the hypotenuse, we just forget about it because it's 1. So now, how can we find this side? Well, we can just simply use the Pythagorean theorem. So we know that x squared plus, I'm going to call this side for now a. So we know that x plus a squared is going to be 1. And if we want to find a, well, we know a is simply going to be the square root of 1 minus x squared, okay? And this is how much you get for a. So now, the only thing that you need to do is, well, we know a is going to be equal to the adjacent side, and cosine y is going to be equal to a. So you get that cosine y is going to be equal to 1 minus x squared, the square root of that number. And, well, now you can just simply plug this value for cosine y into our derivative. We're going to get that, the derivative, I'm going to do like this. So finally, we get that the derivative of inverse sine is going to be 1 over the square root of 1 minus x squared, okay? This is how much you get for the derivative of arc sine or inverse sine, okay? So this is basically one method that you can use to find this derivative, you really need to be careful with the triangle. You don't really want to, you want to be careful with the Pythagorean theorem, because you should get this value over here. And, I believe it's one of the few ways, because I don't think there are too many ways, in which you can find a different value for cosine y, okay? Because probably if you're in an exam, you're not going to be able to deliver this as a solution. You need to substitute cosine y for something, okay? And one way in which you can do that, well, is using this triangle, okay? So yeah, that has been everything. I hope you enjoyed this video, you learned something, and see you in the following one. Bye.